Okay, so here I'm going to take you through the solutions to the Chapter 3 practice exam from AP Classroom for round 2 for the Chapter 3 exam. So sometimes I do them in advance, sometimes it goes faster, and then I can also see when I make mistakes. So in this one here, it's the definition of derivative, guys. It's I got to recognize two things. My function is the natural log of x, and the a value is 4. The derivative of ln of x is 1 over x, and I'll just sub in the 4 and get 1/4. And number 2, it's nothing more. You got the graph of f, and you got this function g. And I want the derivative of h, which is this f of g of x, at 1. So I'm going to do the chain rule. So it's the derivative of the outside, which is f prime. I'm going to repeat that inside g and times it by the derivative of the inside, which is g prime. And then h prime at 1 equals f prime of g at 1 times g prime at 1. So you just got to go searching for things. You got to go shopping all over the place for these values. So I need g prime at 1. Well, this is g. And g prime is just 2. So g prime at 1 is just 2. I don't know why I have, I guess I needed g1 at 3. So yeah, g prime at 1, g prime is equal to 2. You put in a 1 in, you get 2. So g prime at 1 is this 2. And then I need g at 1, and g at 1 is 2 times 1, which is 2 plus 1 is 3. But the derivative of 3, now I got to go to this graph. And the derivative of 3 is the slope of the tangent line at 3. So the slope of this line is the change in y's over change in x's, because here's 3. So the slope of that line is 4 minus the negative 2 over 1 minus 4, which is 6 over minus 3, which is negative 2. And negative 2 times 2 is negative 4. And number 3, once again, it's the definition of derivative, but it's x approaching a constant that's not 0. So my a value is 3, but my function is given to me as ln of x. This represents the derivative of f, everyone, at 3. It's the derivative of this function at that a value. So the function's ln, its derivative is 1 over x. Put in a 3 and you get 1/3. And number 4, this derivative is 1 over 2 root of x. Make this x to the negative 1/2. And that derivative would be negative 3/2 x to the negative 3/2. And then kick it to the bottom. And then just sub in your 4. The square root of 4 is 2 times 2 is 4, so that's 1/4. The square root of 4 is 2, cubed is 8 times 2 is 16. And then 1/4 minus 3/16 is 1/16. 5 is pretty easy, guys. I think you'd get that. Just rewrite that x to the negative 5th, x to the 5th on the bottom, as x to the negative 5th on the top. Drop down the power, repeat the x, decrease them by 1, and it should maybe just make it a match and kick that to the denominator. In number 6, we're going to have to do a product rule. So it's going to be the first function, which is 2x minus 1 to the 5th times 1, plus the second x plus 1, times the derivative of the first, which is drop down to 5, repeat the inside, decrease it by 1, and times it by the derivative of the inside. You don't need to simplify it. Just put in the value of 1 for x, and 2 times 1 is 2, minus 1 is 1, and 1 to the 5th is 1. 1 times 1 is 1. Then over here, 1 plus 1 is 2, and then 1 to the 4th is 1, times 5 is 5, times 2 is 10, sorry. So then 10 times that 2 is 20, plus 1 is 21. When x is 1, I got to put this into here to get y. And I got y to be 2 there. So my setup would be y minus 2 over x minus 1 equals my slope, which is 21. Cross multiply, and I'll get y minus 2 equals 21 times x minus 1. Distribute, and then add the 2 over, and that's what I get. And number 7, some good implicit here. The derivative of 3x is just 3. The derivative of tangent y is secant y squared, and the derivative of y is just 1 dy dx. The derivative of 4 is 0. I'm going to take over the 3, make it negative, divide by the negative secant squared. A negative over a negative is a positive, and 1 over secant squared is cosine squared. In number 8, it's good old-fashioned implicit again. So the derivative of x is 1. This is going to be 2x times dy dx plus y times 2. It's a product rule. And the derivative of negative y squared is minus 2y dy dx equals 0. I'm going to take over the 2y and make it negative, take over the 1 and make it negative, everyone. And I'll factor out that dy dx, and I'll be left with 2x minus 2y. When I sub in the 1, 1, for both x and y here, I get negative 3 on top over 0, which is a d and e. In number 9, again, you got implicit. So it's going to be on your test for sure in a couple of situations. So the derivative of the first, well, it's the first, which is x, and the derivative of the second is minus sine y dy dx, plus the second, which is cosine of y, times the derivative of the first, which is 1. And the derivative of pi is 0 because it's a constant, and the derivative of minus 2y is negative 2 dy dx. I'll take over this dy dx by making it positive, and I'll send this to the other side, making it negative. When I factor out my dy dx, I'm left with negative x times the sine of y plus 2, and I'll divide by that and end up with this as my answer. And then number 10 is calling L'Hopital, because how do we approach a limit? By direct substitution. So I get the limit of the top is 0, the limit of the bottom is 0. Who am I going to call? L'Hopital. So the derivative of the top is cosine, the derivative of the bottom is e to the x. Let x go to 0, both top and bottom, and 1 over 1 is 1. In number 11, f is not differentiable, which means the derivative of f will not exist. Well, that's nothing more than your definition of derivative. This represents f prime at 5. It's the derivative of this function f, which is f prime, at 5. And d should never have been an option at this point. And number 12, I think we may have to call L'Hopital there twice. The derivative of the top is 8x. The derivative of the bottom is 4e to the 4x minus 4. And when I substitute the 0 in again, e to the 0 is 1 times 4 is 4, and 4 minus 4 is 0. So I get 0 over 0 again. So who am I going to call L'Hopital? The derivative of the top of this right here is now 8. And the derivative of this is e to the 4x times 4, which is 16. And the derivative of minus 4 is 0. Let x go to 0. E to the 0 is 1. And 8 over 16 is 1/2. And number 13, it is 0 over 0 by direct substitution. The derivative of the top is the derivative of 1 is 0. The derivative of minus cosine is positive sine theta. And then this down here, guys, got to be careful. You got to take that 2 to the outside. Drop down the 2. So that's 4 sine theta times cosine theta by a chain rule. The sine thetas will divide out. And when theta is 0, the cosine of 0 is 1 times 4 is 4, so it's 1/4. And then 14 here, the derivative of the top is 2x. The derivative of the bottom is cosine of pi x times pi. Because remember, by direct substitution, 1 squared is 1, minus 1 is 0, and the sine of 0 is 0. And then when I sub in the 1, the cosine of pi is minus 1 times this pi is minus pi. So my answer is negative 2 over pi. And last but not least, I would not use L'Hopital's rule because we do get 0 over 0 by direct substitution. But one of our older methods would work here. Just factor out an x cubed, and what's left is x cubed, well, actually 2x cubed plus 6. And then on the bottom, taking out an x cubed would be 4x squared plus 3. These divide out, and when I let x go to 0, 6 over 3 is 2. So once again, some really great problems there. The difference on this one is a little bit more heavy, once again, on implicit differentiation, the definition of derivative, and finding the value of a derivative from different representations. I hope that helps you.